Welcome to the chapter 7.3 lesson video. This is our last lesson video for this chapter. We're going to be talking about the last two cases where we can solve a triangle when we're given a side or two sides and the angle in between, or three sides. In order to solve this, we are going to use the law of cosine. You may also need to use the law of sine along the way, but the predominant thing you'll need is the law of cosine, which we'll talk about here in just a second. All right, so here's our learning targets for today. Basically, we're going to talk about how to solve side-side-side triangles, how to solve side-angle-side triangles, what the law of cosine is, and then also we're going to talk about one more area formula. All right, so solving oblique triangles looks like this. Given any non-right triangle, we can find all the remaining sides. There is a couple cases we already talked about: angle, angle, side, angle, angle, side, side. We talked about the flow chart and how to do all that. We're going to cover these last two cases today: two sides and the angle in between, or three sets of sides. Both of them are going to use the law of cosine in a little bit different ways. We'll talk about that, how to find the missing remaining things. And once again, the only one that we can't do anything about is angle, angle, angle. All right, so here's what the law of cosine says. Now, there's a variety of ways you can write the law of cosines, but the basic one that I like to write down looks like this. It says that any side of the triangle, and in this case A, squared is equal to the other two sides of the triangle squared minus 2 times the other two sides times the cosine of the angle across from the side that we're looking at. Now, I know that probably sounds like a lot of jumbly, mathy stuff, but the idea is that whatever side we're trying to find squared, you use the other two sides in these spots right here, and then the angle across from it in this spot right here. So I can change this up a little bit and use different letters if I want. I could say b squared equals, and then I would write a squared plus c squared minus 2ac times the cosine of the angle across what we were looking for. So we're looking for b, so we would put cosine of b. It doesn't matter which letter is on its own over there. I can write the formula any way I need for my circumstances here. So this is the law of cosine. It's a little bit more complicated looking a formula, so it's a little bit more challenging than the law of sines, but it works just as well. Let's go ahead and put it into practice. All right, so here's our first situation. We're going to draw the triangle picture. Then we can use law of cosine to solve for a missing piece of information, and then figure out how to find the remaining stuff using our other skills. So we'll start by drawing the triangle. So on top, we'll put big A equal to 42.3. Little b will go over here. Little b is 12.9. Little c will go over here. Little c is 15.4. All right, and we need to solve for little a. We need to solve for big B, and we need to solve for big C. Now, we can't do anything with big B and big C right off the bat because we don't have a side and the angle pair. So we have no sides or angle pairs, so there's no law of sines we can do. But we could do law of cosine, and that'll allow us to find little a here. So we'll go ahead and we'll write that out. So the three things we're looking for are little a, big B, big C. But we'll start with little a. So we'll say little a squared equals, all right, little b. Little b is 12.9 squared plus little c is 15.4 squared minus 2 times b was 12.9, c was 15.4, times the cosine of the angle, which is 42.3. All right, so let's recap. We're looking for little a here. We have a little a squared equals little b squared plus little c squared minus 2 times little b times little c times the cosine of the angle that's across from the side that we're looking for. When I plug that whole right side into my calculator, first of all, I'm going to make sure my calculator is in degrees mode. That's something we'll go over in class, and that's over here for this trig function. But I'll type this whole thing into my calculator just as it looks, make sure it's in degrees mode, and it spits out the number 109.6. We'll go a couple decimal places, 998. All right, so that's what a squared equals, but we don't want a squared, we want a, so we'll go ahead and we'll take the square root of that number. So the square root of 109.6998 is 10.47. All right, and there we go. We have our missing side length of A. It is a decimal approximation, so from here on out, everything might be a little different for each person depending on how the decimals were approximated, but as long as you go far enough into the decimals, it should be fairly accurate. Next thing we're going to have to do is find big B or big C. To do that, we actually need a law of sines, so we'll say the sine of A, which was 42.3 over little a, which was 10.47, is equal to the sine of, I'll just do b, big B over little b, which is 12.9. I'll go ahead and cross multiply and take the inverse sine, and I get that big B equals the inverse sine of 12.9 times the sine of 42.3 divided by 10.47. So there's a little bit of math that went on there. But when we plug that into our calculator, we get that big B equals 56.02 degrees. All right, we've now found angle big B. And so all we have left to do is find angle big C, and this is where our job gets a little easier because we already have two of the angles, so we can just do triangle sums. So big C is going to equal 180 minus big A minus big B, and we get that big C equals 81.68 degrees. And there we have it. We solved our triangle. We had to use the law of cosines up here to find that missing side. Then we had to use the law of sines to get one of the missing angles. And then it was nice, we could just use triangle sum to get that final missing angle. It's a little sloppy there, so I'm going to go ahead and fix that so it looks a little bit nicer. 81.68 is what I was looking for there. And yeah, so we've now solved the triangle. Let's try another example. All right, so this one they're giving us slightly different information. So we're gonna start, once again, we'll draw our triangle. This time they don't give us any of the angles, so we can still solve this, but there's a little bit different work to do. A, B, C. We'll still set up our law of sines, but we're gonna pick one of the sides to work with. Now, I don't really care, so we set up all three sides. 9.5, C equals 21.1, and B equals 15.9. And now we're going to use the law of cosine, and it doesn't really matter where we start. We need to find three angles. We need to find A, we need to find B, we need to find C. I'll just start with A. Since I'm going to find angle A, I have to put little a as the one by itself. So I'll go 9.5 squared equals, and then I'll do B and C. So I'll go 15.9 squared plus 21.1 squared minus 2 times 15.9 times 21.1 times the cosine of the angle across from 9.5. Across from 9.5 is A. So cosine of A. Now here's what I'm going to do. I'm going to get A all by itself. So there's a little bit of math to do. What I'm going to do is I'm going to subtract the 15.9, subtract the 21.1 squared, I will divide by the negative 2 times 15.9 times 21.1. So that'll look like this. I'll get 9.5 squared minus 15.9 squared minus 21.1 squared. All of that gets divided by negative 2 times 15.9 times 21.1, and that gets me cosine of A by itself. So what I'll do now is I'll plug all that stuff in to Desmos, and I get 0.90579, that's far enough, equals the cosine of A. All right, so I found my first cosine of A. I will now do the inverse cosine of that number. So I'll do the inverse cosine of that number, 0.90579, and I get that angle A equals 25.07 degrees. So I found my first angle. All right, now I'm going to do a very similar thing, except I'm going to find another angle. So I'm going to do B now. So it doesn't matter which one I do. I could have done C, I could have done B. Doesn't matter, but I'll do the same thing. I'm going to go 15.9 squared equals, now I'll do A is 9.5 squared plus 21.1 squared minus 2 times the first thing, which is 9.5, times the second thing, which is 21.1, times the cosine of this time, we're finding angle across from 15.9 is B. We'll simplify it the same way. So we'll get 15.9 squared minus 9.5 squared minus 21.1 squared divided by negative 2 times 9.5 times 21.1 equals the cosine of B. We'll plug it into our calculator again, and we get that the cosine of B is equal to 0.70504. That should be far enough. I'll take the inverse cosine of that number, so I'll do the inverse cosine of 0.70504, and I get that angle B is equal to 45.17 degrees. 45.17 degrees. And there we go. I now have angle B. All right, I got one last thing to find. To find that one last thing, now all I got to do is triangle sum. So I say angle C equals 180 minus A minus B. So I get angle C equals 109.76 degrees. All right, so this time when we had a side-side-side triangle, we ended up doing the law of cosine twice to get two of the angles, and then our third angle was much easier because we can do triangle sum to get that. All right, let's keep going. There's one catch about side-side-side triangles that we need to talk about. So when it comes to side-side-side triangles, this is something you talk about in geometry as well. Side-side-side only works if the two smallest sides of the triangle, or really any two sets of sides of the triangle, when added together equal something greater than the third remaining side. So that means that 3 plus 4 has to be bigger than 5. 4 plus 5 has to be bigger than 3. 3 plus 5 has to be bigger than 4. Really, the main one you need to check is that the two smaller ones, when added, are bigger than the biggest. So 3 and 4 make 7, and 7 is bigger than 5, so this triangle is possible. If you have something like this, 2, 4, 7, 2 and 4 make 6, and 6 is not bigger than 7. So if you got this problem as a setup where it said little a is 2, little b is 4, little c is 7, you would say there is no triangle. You could just say no triangle and be done with the problem. The reason that is, and you can kind of see from this picture right here, is it creates what I like to call T-Rex arms. The triangle has a base, but then it has these two little sides right here that are these little stubby T-Rex arms that aren't long enough to meet up. This one only goes to here, this one only goes to here. It's missing that gap filler. No matter how we swing this side around, it'll never meet up and make a nice point of a triangle. Since that's the case, we have no triangle. If the two smaller sides add to be greater than the bigger side, then it will always be able to make a triangle in some way or another. So when you get a side setup, you should absolutely check this, because if you don't check this, you'll start doing some math and you're going to run into a bunch of weird issues. So make sure you check this first and foremost, that the two smaller sides add to be bigger than the third. If they don't, you just write no triangle and you get to be done with the problem. Quickly recapping, we kind of have four different types of problems. Case one, you're given angle, angle, side, or angle, side, angle. You're going to find the last angle with triangle sum, and then find the missing sides with law of sines. Case two, you're given angle, side, side. You have to use your flow chart to figure out whether there's 0, 1, or 2 triangles. Then you're going to use the law of sines and triangle sum. Case three, you're given side, angle, side. You're going to find, with the law of cosines, you're going to find one of the sides. You're going to find one of the angles with law of sines and then do triangle sum. Case four, you're going to see if the triangle meets the restrictions that two sides are greater than the third. And then you're going to use the law of cosines to find an angle. And then you have choices. Here I said you could use the law of sines and triangle sum, or you could use law of cosines again, which is what we did, law of cosine again, and then triangle sum. It doesn't really matter. The second angle you can get with law of cosine or law of sine, whichever one you're more comfortable with, but the first one absolutely has to be done with law of cosine. I like to do cosine, cosine. That's just my preference. All right, and here's our last thing for today. And this is a new area formula for a triangle, and this one is quite unique. It says if I have the 3 side lengths of the triangle, only the 3 side lengths of the triangle, I can find 2 things, and it'll give me the area of the triangle. The first thing you'll find is this thing called the semiperimeter. A semiperimeter is given by the formula S for semiperimeter is equal to 1/2 of the sum of the side lengths. So you add up all 3 sides, divide it by 2, and that's this thing called the semiperimeter. And then to calculate the area, you're going to do the square root of the semiperimeter times A, the semiperimeter is minus A, times the semiperimeter minus B, times the semiperimeter minus C. So it's S times S minus A times S minus B times S minus C. So once you find this thing, you have to use it 4 separate times in this same formula. Let's go ahead and give it a try. So first thing we're going to do is we're going to find our semiperimeter. So to do that, we're going to say S equals 1/2 of A plus B plus C. So that's 9 plus 15 plus 21. So we'll go 9 plus 15 plus 21. Use your calculator for that. You get 45. You're going to divide the whole thing by 2, and you get your semiperimeter is equal to 22.5. Then I'm going to calculate the area. To calculate the area, I do the square root of my semiperimeter, 22.5, times my semiperimeter, 22.5, minus A, which is 9, times the 22.5 minus B, which is 15, times the 22.5 minus C, which is 21. We're going to multiply that all together in our calculator, and when we multiply it all out, we get that the area is equal to approximately 58.46 units squared. All right, so it's an interesting area formula. It's a little bit different than any other area formula we've ever really seen, but it works just the same. You find that semiperimeter, you plug it into our formula, and it gives us the area of this specific triangle. All right. With that, you should have enough information to be able to get started on the homework. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.